not sure how long how long that took, but if anybody has any questions, I can maybe you could let me know if there's any in the chat.
Thank you. Yeah, I don't see any questions yet.
Okay, so I'm on multiple screens as well, and paranoid about the the leaf blower. But I know we're going to hear from our amazing Eco Club next. So all of the things that we talk about in youth education all comes together within our Living Labs project, and we really look at how we can make those connections, and we think about the impact that this project has on the lives of the students and of course the environment as well. Oh, and here's Scott. Here's Scott right now. So I think we are on time. So I can pass you over to Scott if you would like.
Sure. Thank you, Claire. Hi, everybody. Thank you for having us this afternoon. As Claire mentioned, we are the Saguaro Environmental Club. I'm here with several students from the Environmental Club, and we are going to talk to you today about the Living Labs project that we've been working very closely with McDowell Conservancy on. Give me just a moment to share my screen. Can everybody see this? Let me make this full screen. Okay, so what you see on my screen here is this GIS story map that our students have put together. And the purpose of us putting this presentation together in this manner, rather than a regular PowerPoint presentation like what these students may normally do, is so that they could create a living document to be used as a template for other schools, hopefully within the district, but also in other parts of the state, to use this as a template. So first, quickly, we want to say thank you to the Conservancy for having us and for inviting us and for allowing us to work closely with them on this project. Over the next 20 minutes or so, you'll hear from 5 students that I have here from the Saguaro Environmental Club about the massive project that they've been working on this year with multiple community partners, including the McDowell-Sonoran Conservancy, researchers at Northern Arizona University, community members from the Scottsdale Leadership Group, and faculty at Scottsdale Community College. All of that culminated in these students working very hard for many, many months to create the first ever living laboratory on our high school campus, and the first one to exist in our district, but hopefully not the last. So the first experience to start this off, as Claire mentioned a lot about, was actually a field trip to the McDowell-Sonoran Preserve, as you can see here, where the students had an opportunity to engage in all kinds of activities, from staff scientists at the preserve and stewards at the preserve who took students around the native Sonoran habitat and allowed students to interact with what they were seeing in the environment around them. As you can see in these pictures, that experience included students interacting with ongoing biocrust and restoration research projects, collecting Seek and iNaturalist biodiversity data, learning about soil infiltration tests and how to collect that data, and just overall practicing observations of the natural world, which included nature journaling and also sketching their observations in their personal journals, which you will hear some about in just a little bit. So this is just a quick snapshot of some of the activities that these students had an opportunity to do, but definitely not everything that we were able to be involved in at the Conservancy. Over the next few months, once we returned back to our high school campus, the students were quickly involved in a whirlwind of projects, trying to incorporate these different experiences from the preserve into things that we could do on campus. So here in these 2 pictures, you see a small group of our environmental club students performing the first soil infiltration tests on our soon-to-be saguaro nurse condition plots, which you'll hear about soon. And after they did these soil infiltration tests, they quickly ran with everything that they learned from the Conservancy, including taking a biodiversity index of our campus and quickly removing invasive species, which you will also hear about soon from a couple of our club officers. So before I turn it over to the students, because this is really who that is all about, I wanted to just quickly give an overview of the 3 major components of our project this year that we worked closely with the Conservancy on, as well as many other community members. So our project had 3 major components, which involved removing invasive grasses and planting a native pollinator garden, designing a vertical biocrust garden, and designing and planting a saguaro research plot, which included 40 saguaro cactus, nurse plants, and different nurse conditions for a controlled research experiment, which was in close collaboration with NAU and the McDowell Sonoran Conservancy. The students that I have with me today will talk in much more detail about those projects. But before I turn it over to them, just quickly so that everybody knows the purpose of this project, the overall goal is for us to provide a campus ecosystem that is sustainable and can be used as more than just a garden, but as a laboratory to be incorporated into curriculum, not only in science classes, but also in classes across the school ecosystem itself. So in doing this, students have had an opportunity to engage each other in loving the natural world and learning how to collect data, but also have had an opportunity to learn about themselves and why they're interested in science in the first place. So I have 5 students here with me today from the club. I want to just quickly introduce them, and they're going to do most of this presentation. The first couple that I have to introduce to you are 2 of our officers, Claire Holtree and Sadie Williams, and then they will be turning it over to Nikhil Sethi, who will be presenting a section that was done with another officer of ours, Kate Dalton, who unfortunately could not be here. And then they will transition to our final 2, Giovanna Raboin and Marco Bartoletti. So without further ado, I will pass this off to Claire Holtree and Sadie Williams, who will present the first aspect of our project. Claire and Sadie, here you go.
Thank you, Mr. Milne, for that amazing introduction. I'm Claire.
I'm Sadie.
And as he stated, there are many components that make up the empire that is the Living Labs project. We are about to touch on the pollinator garden, which is one of the 3 of these components. So we would love to elaborate on this project and how it came to be. So in the initial stages of this project, we used the app Seek and iNaturalist to kind of get a general idea of the biodiversity that existed on our campus at the time. Unfortunately, we realized that that biodiversity was extremely lacking. And although this saddened us, it also gave us hope for the future of our project, and it gave us ideas and optimism.
So the first thing that we did was collect initial data of our campus. So we split our campus into 8 similarly sized study areas, and pairs of students walked each area and collected the data on all of the species that they observed. Initially, as Claire mentioned, we didn't observe much biodiversity on campus, but since planting our pollinator garden, we have observed noticeably more species on our campus.
Now, in this initial process, we did write down some of our observations and journal entries, as Mr. Milne mentioned. And these journal entries are only glimpses into our minds in the initial stages of this project. As you can see, we were optimistic stepping into this project, and evidently it did pay off as we channeled our hope into hard work, which is how Living Labs came to be.
Throughout this process, we also learned about some plant adaptations that are made in the desert biome. Here are just a few examples that plants make in the desert. And if you'd like to learn more, we've included a link in this box.
Now, given this is the pollinator pathway garden, we did learn about the important association of pollinators with the native species that we planted. These are some snapshots of us planting these native species, and we really did just learn the value of teamwork in this process. As you can see, we really did make a day out of each of our planting sessions, and we overall grew closer as a club. And when we began, when we first started the hands-on implementation of our garden, we first had to start with removing the invasive fountain grass that plagued our campus. I'm sure, as everyone here is aware, fountain grass is invasive to our Arizona wildlife, and it does not promote the biodiversity that we were looking for. Therefore, it had to go. And as you are all aware, these plants are extremely heavy and overall massive, and so it really did take a village to remove each one, but we used the power of teamwork to ultimately get them out of the ground and replace them with new native species. It was very fun overall.
So here are some more journal entries that we wrote from the removal of the fountain grass. It was really amazing to get such a hands-on experience and to be able to take part in moving towards our ultimate goal.
And here are a few more photos of the plant removal and planting process. You can see us doing the labor-intensive work right here, but what mattered is that we were doing it together. We had a lot of fun, as you can see, some silly moments riding around on Mr. Milne's tractor and carrying the fountain grass to an alternate destination.
And then here's us planting the very first native species in our pollinator garden. This was such a surreal moment of finally all of our hard work paying off.
And when we implemented this pollinator pathway garden, we did, Kate Dalton, who couldn't be here with us today, did make this amazing graph, kind of showcasing and organizing the various species that we hold in this garden in a very color-coded and organized manner.
So in our garden, we have a couple annual plants. This includes the lupin, which attracts bees, the skeleton weed, which attracts butterflies, and then the deer vetch, which attracts hummingbirds. And those are just a few examples of the plants that we have in our garden.
And here we have some photos of our some of the various wildlife that we have in our garden in bloom. This desert marigold, for example, started off as just a minuscule little flower, but as you can see, it's just beautifully blossomed, and it's just been beyond rewarding to actually see visually the results. And we came to the conclusion that our overall goal through this pollinator garden is not only to attract various species of wildlife and to increase our biodiversity on campus, but also to create that vital connection between the community and wildlife that is so important in any restoration project.
And finally, we'd like to share with you some of the pollinators that we have seen on our campus since the planting of native pollinator species. It's been so cool to be able to already see the changes in biodiversity on our campus. And we've also included this hummingbird and honeybee sound that you're now able to hear in our garden.
Now, as previously mentioned, the pollinator garden is only one of 3 components that make up the Living Labs project, and I will turn it over to Nikhil Sethi to elaborate on the second portion of our project. Thank you.
Hi there, my name is Nikhil, and I am going to be sharing with you about the saguaro nurse condition experiment that is a major component of our Living Labs project. And I did just want to say thank you to Kate Dalton, who is not with us today because she is not feeling well, but she contributed greatly to this presentation, and we are very grateful for her. So the way that this project kind of got in the ground was thanks to the Conservancy, who shared with us this idea of nurse plants and nurse conditions. For us, this was a relatively new subject, but we found it to be very important, interesting, and compelling, especially because of its great focus on conserving important species like the saguaro cactus, which is a keystone species, as I mentioned, and provides great benefit to the different plant and animal surroundings in the desert, which I heard was mentioned earlier in the symposium. But we were very excited because we were able to take a hand in conserving saguaros. So we were instantly excited about this project, and we decided to do some research into our nurse plants, nurse rocks, and nurse shade conditions to find what the possible benefits of including them and researching them would be. So we discovered that the existing research on nurse plants has shown that they are able to help saguaros against outside factors that may be of harm to them, such as human impact and excess heat, as well as helping to lock in moisture for saguaros. So we were excited that all these conditions may be able to positively affect the growth of these saguaros, and we were really ready to get started. So after some meetings with the Sonoran Conservancy and also with Scottsdale Community College, we got started on actually breaking ground on this planter. So this planter had not been touched in multiple years, and a lot of this project came from the idea that we wanted to bring some biodiversity to our campus and re-beautify it. So this planter had been an eyesore for a couple of years with nothing really left in it. So when we came through to get started on this project, we tilled the soil, and we had great help from saguaro facilities, and we were very thankful to Joe Arteca for helping us with a lot of this work. But we were able to till the soil, dig out the walls of the planter, as you can see here, and redo them just to make sure that we were safe to plant within here. And break some ground on this planter. And as you can see here, I know Mr. Mill mentioned this briefly earlier, but this was a big component, was installing these irrigation lines, a skill that we didn't necessarily foresee ourselves learning, but this was one that was of great interest to a lot of our club members and was exciting to learn more about irrigation. And this is the next step of the progress. We were able to re-level this planter and start measuring out where all of these saguaro plots were going to be. So we were making sure that everything was controlled and consistent when we were making these plots, even, and so that we can install even plots for each of the 40 saguaros that would eventually be a part of this planter. So that's the progress that we made to get to the point where we were able to actually get started on bringing in the saguaros and the nurse conditions. So with the help of Scottsdale Community College, the Scottsdale Leadership Group, Dr. Rowe, who I know is with us today, Dr. Rowe from Northern Arizona University, and the Sonoran Conservancy, of course, we were able to make this vision a reality. So after we did this research that we were able to learn more about nurse conditions, we were able to actually get started on the planting aspect. And thankfully, we had Scottsdale Community College to help us and aid us and also provide us with great advice along the way. They provided us with our triangle leaf burr sage nurse plants, as well as our saguaros that we put into this planter. We made another fun day, another fun couple days, the weekend that we planted all of these saguaros and nurse plants. We had a lot of needles stuck in our hands at the end, but it was still a really great experience. And regardless of the needles, we were super happy that we were actually able to get all of these plants in the ground so that we had an operational living lab at our own school, which is an idea that we had thrown up before, but we were actually excited to see it here in physical at our school. So once all of this planting was completed, I'll show you some of these images here. This is one of our experimental plots, and this shows all three nurse conditions. We have a saguaro here in the center. We have a triangle leaf burr sage nurse plant and a nurse rock, which is a cinder block type material. And we have this nurse shade condition right here. And here's a animated representation of that. And this is our saguaro planter as a whole. And as you can see, there are various assortments of different nurse conditions so that we can see how the various conditions impact their individual saguaros. And a great thing that Dr. Rowe provided for us was this entire experimental design, which was able to be greatly educational for each of us because we were able to see how to form a experiment in an actual laboratory, which happened to become our school. And she was able to share with us how we can accurately and concisely create data points based off of this planter. So I actually got to meet her and discuss with her the different aspects of this project. And it was a very exciting and very informational for me and for other students. And after she shared with us all of the different aspects of the saguaros that we should be measuring, we got to work measuring some of this baseline data so that over time we'll be able to expand and continue to monitor the growth of these saguaros. So as is seen in this journal entry right here, we're discussing the process of planting the saguaros. And we started from pretty bare bones with just a lot of dirt, as you can see in these photos. And then we were able to get all of the saguaros in and planted with these cages to protect them and also provide the nurse shade conditions. Here's some more photos. And once Dr. Rowe was finished advising us on what we should be measuring for these saguaros and how we should go about doing them, we started measuring the size, height, width, and the number of ribs and areoles on these saguaros so that over time we'll be able to see how the nurse conditions are affecting their growth and that we can hopefully yield some positive results as compared to the nurse plots that do not have any nurse conditions or nurse plants. So we did experience a couple of roadblocks on the way to getting this data. After the weekend following the day that we planted all the saguaros, we noticed that all of our cages were tossed about surrounding the planter, and that there was clearly an issue that had occurred to cause this to happen. And we originally imagined that it was a vandal, and we were lucky and happy to realize that after looking at security camera footage that it was just a microburst. But this was educational for us because we know that we need to continuously monitor our plot as we had previously thought, but also that we should ground staple in our cages to make sure that they don't get tossed about by the wind. And also, after a couple of weeks being planted, the nurse plants, the triangle leaf burr sages, we had experienced some dryness due to the hot Arizona sun in the beginning of this hot season. So we did have to replace 2 or 3 of these burr sages just to ensure that they were living and thriving. But we did learn how to monitor for new growth and make sure that all of the birth stages are healthy and consistent throughout the plots. So here's some photos of taking those initial measurements, again, of size, height, width, and more stats on each of the saguaro cacti. And this was a learning curve for us, as we all had to communicate and make sure that our measurements were consistent. So after some practice, we all got there and were able to take these measurements and ensure that they're all consistent. And here's a before and after of this plot with all the different saguaro plots, each one being surrounded by an individual cage right here. And now we're very excited to see how this project grows and continues. We know every month we're going to continue to collect data on this plot and see how these nurse conditions are positively affecting the growth of these saguaros. And hopefully this can be handed down through multiple generations of students, as the saguaro growth cycle is a very long one. This is a project that can be maintained by generations of students to come. And to bounce off of that, we're very excited of the potential of this expanding to other schools in our district and around our state, so that other students can learn about the benefits of conserving different keystone species and also can learn how to conduct their own lab on their campus. And we're already starting to share this with other students, but we're excited to share it with even more students. So now that we have some real progress on the ground with this planter, we're super excited to see how it goes. And from that, I'm going to deliver the presentation to our next presenters, Gian and Marco, who are going to share with us what we learned about BioCrust and about our vertical gardens.
Thank you, Nikhil. Okay, so I am Giovanna, also known as Gian.
I'm Marco, also known as Marco.
So as Mr. Milne previously mentioned, we were fortunate enough to go on a field trip to the Conservancy. And there we were able to learn about a little thing called BioCrust. At first, we all thought it was just, dirt. But as time went on, we learned what BioCrust actually is. And it sparked our curiosity to want us to learn more about it at our school. So we're going to start off with, what is BioCrust? As you all know, BioCrust is like the skin of the earth. It is a community of moss, cyanobacteria, and lichen that hold the top layer of earth together. It is kind of like a Band-Aid. So this is a quote from one of our members when they first saw BioCrust, and how at first they thought it wasn't really anything, and then soon came to realize how cool it is. Something we also learned was how BioCrust benefits the environment. We learned that BioCrust helps restore areas impacted by human land destruction, and that it holds down loose dirt during dust storms, as well as prevents landslides, retains water, and prevents water runoff, which is very important, especially here in the desert, because we don't often get storms and a lot of our land has trouble absorbing the water.
All right, so I'm going to talk about some threats that affect BioCrust. So one of the main threats to BioCrust is human impact, and this can come in many forms. One of the main ones being people going off trail. When they go off trail, they can walk around and step on BioCrust, which will destroy it. And that's very bad, as BioCrust takes decades to form. Another threat to BioCrust from humans are off-road vehicles. So these can be mountain bikes, dune buggies, or motorized vehicles. And just like people, they will dig up the ground and destroy the earth around the BioCrust. Another threat to BioCrust is global warming. What this does is create less stable soil, which will slowly degrade the BioCrust, limiting its impact on the environment. And another threat, which is especially more recent and more damaging to the BioCrust, is solar farming. So when solar farms are made, they have to dig up large areas of land to make space for the solar panels. So by doing that, they destroy all the BioCrust in the area. But once solar panels are in place, they create a perfect environment for the BioCrust to thrive. So it's kind of like a double-edged sword in the fact that it will destroy them, but it's also a perfect environment once they're in place. And then if we scroll down a little bit, you can see pictures of where our BioCrust will be living next year. You can kind of see how they started off as just plain whiteboards and how they turned into pieces of art. Right now, we currently have 4 on campus, but we hope to someday expand that. And this quote down here kind of describes how we feel about the BioCrust vertical gardens. And I'd just like to thank one of our members, Ari, real quick, for the wonderful work they did on the artwork. And I'll hand it back to Gian for current research on BioCrust.
As Marco mentioned, we want to have BioCrust living in our vertical gardens in the upcoming school year. And we also want to do research on it. So to do this, we decided we must learn about what other people are doing with BioCrust. Here are a few things we found interesting when we were researching. So one of the things we learned about, which the Conservancy actually told us about, was how BioCrust helps stop the spread of valley fever, which we found very interesting, especially considering valley fever is very present in Arizona where we live. Another thing we learned is that people are taking healthy BioCrust from certain regions, fostering it in labs, and attempting to replant it in other regions where BioCrust is crucial. They hope that this will help the BioCrust there and that they will adapt and just make the environment thrive. Something that we found interesting while we were also researching was how people are taking samples from the Mojave and Sonoran deserts where we live and implanting them in the Colorado Plateau to help combat climate change. The hope is that because the Mojave and Sonoran Desert BioCrust is already adapted to harsh environments and high temperatures, that by putting in the Colorado Plateau, they will adapt in the plants and environment, they will thrive and just become better.
All right, and then some future ideas for research on campus. So the first one will be to expand our vertical gardens. As I previously stated, we only have 4 on campus, but we have tons of trophy cases around all the buildings where we can implant more vertical gardens. So we hope to someday have like a network of gardens around campus where we can be growing BioCrust. Another idea that we have is to make BioCrust in a lab, if that makes sense. We have a great biotech program running on campus right now, and we hope to somehow be able to make BioCrust in a lab. Our next idea is to observe the differences in BioCrust depending on its environment. So we mean to take some BioCrust from the Sonoran Desert and compare it to BioCrust, say, in Joshua Tree Desert. And we hope to see what the differences are in the BioCrust depending on its environment and what animals live in the area. And then finally, we hope to someday next year allow students to do their own projects with the BioCrust and let them have their own ideas of what they want to try out with it. And we hope to be able to expand the environmental club and get new members through this idea. I'd like to thank you all for having us, and I'll hand it back over to Mr. Millen for some closing remarks.
Okay.
As you can see, these students have quickly developed a strong passion for this project and could talk about it for days. So I don't want to take up too much longer of your time so that you have time to ask them some questions about this project. But I just wanted to quickly show you really our 4th and final component of this, which was creating a graphic roadmap of this vision, which the students did live with all of the partners that we worked with and had an opportunity to brainstorm their ideas while those ideas were represented as this graphic drawing that you see here live in the classroom. So this is now hanging up across the hall from our vertical BioCrust gardens and serves as a reminder not only to these students, but to everybody else in the school about the path of the project and what we have in mind for the future. And the purpose is to keep us on track and encourage engagement for future years to come. So before we open up, I think hopefully we have time for a couple questions for these students. I just wanted to give a couple last minute thank yous to everybody. We had a lot of help on this project, as you guys heard. So a quick thank you to the McDowell-Sonoran Conservancy, Northern Arizona University and Dr. Helen Rowe, Scottsdale Community College and the Center for Native and Urban Wildlife, the Scottsdale Leadership Group, Johanna Kaiser and SUSD, and of course, Joe Arteca and our SUSD facilities team, who did a ton of work behind the scenes to get us to where we are today. And at that, I think we hopefully have some time for some questions, which I will let the students field for you guys, if anybody has any. Thank you all.
Thank you guys. I think everyone on the calls, I'm sure, is super impressed. I thank you to Claire and to Dr. Rowe for all their help, and to Mr. Milne. I have 2 kids, and I just personally would like to say thank you for inspiring interest in science, and the students. You guys are. It's encouraging to see your energy and curiosity. All I'm seeing is a bunch of compliments on how well you guys did. So I'm looking for questions, but it looks like a bunch of compliments on how well you guys did.
We're happy to hear that. Thank you. They've been very excited about this presentation, and I think it was apparent how passionate they are about this project.
Most definitely. And hey, always down the road, hopefully you guys have some interest, if you're not too busy doing bigger and better things, to see you out there helping out as stewards.
Of course.
100%.
Yes.
They're all looking forward to more field trips to the Conservancy next year for sure. It'll be a big part of the plan.
Awesome. I don't know if there's any questions out here. Melanie, I might turn it back to you at this point, but
I
I'll
got one in
keep,
the chat, Lars.
What's that?
I just put one in the chat.
Okay. Isn't the school work paired with areas in the preserve? Can you discuss that?
Do you guys want to talk? So I'll let the students talk about that a bit. We have unfortunately not had much time this year to start on that, but part of our vision for next year is to pair basically restoration plots on our campus with restoration plots at the preserve, so that students can collect data on both of those and see how restoration efforts may be different in a sort of more urbanized environment here versus a more rural environment in the preserve. And maybe you guys can elaborate on what you hope to see with that.
Sure. Yeah. So definitely one of the key interest points of when we initially began this project was that urban and rural difference, not necessarily rural, but urban and wild habitat difference, and see how that impacts, say, for example, in the instance of the pollinator garden and the saguaro pathway project, we wanted to see the differences of growth and development and also species presence, based both on our very urban location of our high school as compared to the relatively untouched landscape of the Conservancy. So we hope that next year we can work very closely with the Conservancy on this aspect of the project. But that is definitely something that we jump started over here, is starting those observations of how these projects are coming along in our environment. And we hope that down the line, we're able to make some great comparisons to what we observe in the Conservancy in the same controlled environment.
Awesome. Thank you. And there's one more question. What has been the most fun and most challenging part of the process so far? To anyone?
I'll jump in. I can definitely say one of the most fun parts of this entire process has been the hands-on labor-intensive work that we did as a club. This may seem rather ironic considering when one hears labor-intensive work, well, that doesn't sound very fun, but the aspect of working together on the even the more challenging parts of this project is really what made us closer as a club, and is really what brought our ideas to life, I'd say. So ironically, the labor-intensive work is what would have been one of the most fun parts of this project.
Yeah.
It would also be one of the more challenging ones as well.
Yes. It goes hand in
It
hand.
was amazing to take these like challenges that were presented to us and just like be able to have fun with them. And I mean, in a club, like we're working with our friends. And I think especially removing the fountain grass was really fun, because we kind of just messed around and just like had fun while also, you know, learning about like the invasive species.
Yeah, as Claire stated earlier in the presentation, by doing the labor-intensive work, this also made our club members a lot closer and just allowed us to have a lot more fun than we would have thought we would have had digging holes in the dirt.
I would definitely want to jump in and mention, rather than not necessarily a challenge, but certainly something that was a great adaptation for us. I briefly touched on it, but something that was new to us was this kind of experimental design and conduction of a very controlled experiment, which is something that we have not personally, I can speak for all of us here, we have not personally conducted ourselves before. So starting from scratch, but also with the advice from other stakeholders that assisted us in this project, that was really able to open our eyes to how to conduct this project and how to make sure that all of our experimental data was very controlled and very accurate. Because we wouldn't have known fully how to make sure that everything was in order without the advice of all these other groups that advised us in the correct direction.
Awesome. Thank you guys so much. Great.
Thank you so much.
Thank you all for inviting us. We appreciate it.